Dear students, in this video lecture, we are going to learn about a silicone material. And this is a special kind of material which possesses inert synthetic compounds with variety of forms and uses. And these materials generally are heat resistant, rubber like, and they are used in sealants, adhesives, lubricants, medical application, cooking utensils, and insulation. Silicones are generally polymers that include silicon together with carbon, oxygen, hydrogen, and sometimes other elements. Some common forms of silicone includes silicone oil, silicone grease, silicone rubber, silicone resin, and silicone chalk. So generally, the silicone is a polymer material which is possible in many different forms. The major content of silicone is silica, and along with silica, some carbon traces will be there, hydrogen traces will be there, oxygen traces will be there, even some metal traces will be there. So, as we said, it can be in many different forms as fluids, dispersion, emulsion, and can be used for lubrication purpose. It can be used as resins and etc. What makes them special? Why this silicone is so special is because of its very good, excellent properties. See some of the properties of silicones. So it possesses very low chemical reactivity. Generally, silicone does not react with any of the chemicals, and it is low toxicity. That's why in many cooking utensils, silicone has been used. If it is toxic, we cannot use as used in cooking utensils. In many cooking utensils, as well as even in certain surgical instruments, can be made up of this material. The thermal stability, uh, it possesses a very good thermal stability. It can be from 100 to 250 degrees Celsius. Even it can withstand a temperature of 250 degrees Celsius. The ability to repel water and form watertight seals. So this is one of the special property of silicone, the ability to repel water and form watertight seals. For example, even silicone can be used as mold to make ice. So because the water repulsion is more than absorption, so it has a very good repulsing. It repels the water more efficiently when compared to other material. Does not stick to many substrates, but others well to certain materials. So most it does not stick to many substrate means some any such bases, but especially with glass, it others well, and also it depends upon what forms it exists. It exists in as a crease, or it exists in the form of um, either it is in the form of grease, or it exists in the form of rubber. That depends on that. It others well, generally the other well with glass material, and it does not support microbiological growth. Any microbial growth will not occur. So generally, for example, if there is if any cooking vessels made up of some metallic alloys, for example stainless steel or some other material, even the some food particle traces is there, it may give rise to certain microbiological growth, like for examples, some bacteria can be formed, or virus can be formed, some fungus can be formed. This microbiological growth will not occur if we use silicone material. So it does not support any microbiological growth. That is its specialty. The resistance to oxygen, ozone, and ultraviolet. This resistant to oxygen plays good. Okay, it possesses a very good gas permeability. That's why it is used to transmit oxygen in hospitals. We cannot use any kind of material to transmit to supply oxygen to patients, because if that material absorbs the oxygen, then it cannot supply uh, maximum amount of oxygen cannot be transmitted. Some amount can be lost, but that will not happen if you make such tubes using the silicone material. And it possesses a very good electrical insulation behavior. So it is electrically insulating material, so it is not conductive. And it can silicon can formulated to be electrically insulative or conductive. It is suitable for a wide range of electrical applications. In that sense, generally it is electrically insulative nature, but it can be conductive by adding some suitable metals within that. For example, if smaller amounts of some copper oxide, copper ions can be present as a impurity phase, then we can make it as conductive. So like that, it can vary from insulative even to conductive, but mostly it is insulative in nature. And as I told, the gas permeability and resistant to oxygen, it plays a very important role in transmitting oxygen in hospitals. So synthesis, how it can be synthesized? Mainly it is synthesized from silica, which is common in sandstone, beach, and similar natural materials. It can be used as an initial material, but mainly silicones in industries can be formed using chlorosilanes or tetraethoxysilane and its related components. Here, a procedure is given which is synthesized from polydimethyl siloxane, which is used as the produced silicone material is polydimethyl siloxane, and the starting material used is dimethyl dichlorosilane, which reacts with water to form this silicone material. And this is the formula through which the silicone is synthesized. And this is the general formula. This is the formula which is synthesized from dimethyl dichlorosilane, and this is the general formula to synthesize from chlorosilanes or tetraethoxysilane or any different starting material, and through this we can synthesize. And the polymerization typically produce linear chains capped with silicon hydroxide or silicon chloride groups. Under different conditions, it is mostly cyclic and not chains. The applications of silicone are: it is used in aquarium joints. Silicone used to join glass plates as it other well to glass plates. In automotive industry, silicone grease is typically used for lubricant purpose, and it can be used as films, and silica based substrates can be used substance as glass to form covalently bond hydrophobic coatings, and it can be used as a film. It can be used for coatings, and it is used in cookware. It is used for, as I told, chocolate molds, ice cream molds, muffin molds can be made using this. And in dry cleaning, silicone liquid silicone can be used as a dry cleaning solvent, and which is environmentally friendly. And apart from that, in electronic industry, electronic components are sometimes encased in silicone to increase stability against mechanical and electrical shock. So like that, it possesses a very wide range of application. And this kind of process, the process through which the electrical components are placed inside a silicone material is called as spotting. So these are the applications of silicone. So the remaining we see in next lecture.